In this figure, we're looking at the coupled processes of primary and secondary active transport. Primary active transport, shown here at the top, is when we utilize ATP directly to transport solutes into and out of the cell. Now, oftentimes, lots of cellular work is done utilizing ATP directly. However, in some cases, we don't use ATP directly. We use gradients generated through the use of ATP to do work. And that's what's happening in a case of secondary active transport, which we'll look at here on the left and on the right. Now, let's come back to our primary active transport for just a second. Our transport protein here, I'm coloring it blue for a second, is moving sodium out of the cell and it's moving potassium into the cell. And what this does is generates a gradient for sodium where the sodium is higher in concentration outside than inside, and vice versa for potassium. We put a big K on the inside and a little one on the outside to indicate those concentrations. Now, if we focus on sodium for a minute, what that means is that sodium would tend to diffuse down this gradient from high outside to low inside if it were given a pathway. Let's come down to our secondary active transporters. We're going to utilize that sodium gradient driving inward into the cell to do work. On the left here, we're going to do co-transport. We're going to move two solutes both in the same direction. The sodium is moving down its gradient, so we're releasing stored energy, whereas another solute, such as a nutrient possibly, would be driven into the cell uphill, up a gradient, to where it's in greater concentration, right? That's energy requiring. We're getting that energy from the sodium gradient. Similarly, but somewhat oppositely, on the right side here, we're going to show you countertransport. We're still utilizing the sodium gradient, again, driving inward always, but in this case, we're going to utilize it with a countertransport protein to move a solute out of the cell. Right? When the two solutes are moving in opposite direction, now it's called countertransport. It's still utilizing the sodium gradient for energy. We're just moving the two solutes in opposite direction. And these transporters are very essential to cellular function because of their importance to generating the gradients, such as the sodium gradient or the potassium gradient, as well as moving other solutes, essential solutes, either into the cell or out of the cell, utilizing the co- or countertransport proteins. It's always important to note that primary active transport and secondary active transport are always found together in the same cell.